Hi, this is section 1.2 quadratic equations. This is going to be a two-part series for section 1.2. And what we're doing on this one is we're solving quadratic equations. Part one is, as a matter of fact, this is also a intermediate algebra concept that, so if anybody who's in Math 135 should have seen this already before anyway. But this is just kind of a really quick review of it and how to do these types of problems. The quadratic equations is ax squared plus bx plus c equals 0, where a, b, and c are just real numbers. And this is actually what we call general form. And so what we're going to do here is we're going to try to solve equations of this form. And but there's three ways to solve it. In Math 103, you probably learned all three of these, specifically the first one and the third one. The second one in here in Math 135, we don't talk so much about that. This is one thing we did decide to cut out of 135, and that's completing the square. So when we're solving these equations from 1.2 and, matter of fact, 1.3 as well, we're going to either factor them or use the quadratic formula. Factoring is just, and that in itself is, there's several ways to be able to factor. One way of factoring is called the guess and check method, which is the method I will use. And then another one is called the AC method, and there's other methods as well. And no more than you have to factor here is probably the guess and check method is sufficient. There's no sense of having to learn a new system, and plus there's so many different ones. So factoring is always kind of, the guess and check method is the one I've always stuck with. So, but the other technique was completing the square, and the other one's quadratic formula. The good thing about the factoring method is that it's really easy and very quick if you can guess quickly. For the most part, those are simpler. But the problem with factoring is they don't always factor. And so when they don't factor, if that's the only thing you know how to do is factor, you don't know the quadratic formula, if you don't know the completing the square method, then you're kind of stuck. So factoring is good if it works. If it doesn't work, there's the quadratic formula. And the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And the formula is nice to use. It always works. And by the way, the a's, the b's, and the c's in this formula are the same a, b, and c in this number. So the number in the beginning is what you would put in right there and right there. The b in the middle term you'd put in right there and right there. And then c you'd put in right there, what those numbers are, and then work it out. And there should be two answers. They may be distinct. They may be different, in other words, or they might be the exact same number. So, but there are still two answers. Now, the b squared minus 4ac, if that is positive, there's going to be two real solutions. And for the most part, 1.2 questions, that's going to be the situation. And when the b squared minus 4ac is less than 0, those are going to be two complex solutions, and that's 1.3 type questions, which we'll talk about that in a minute in my next part, not the next part, but my next series. So, by the way, the b squared minus 4ac is called the discriminant. You don't need to know it, it's just the name of it. So if somebody says whether the discriminant is positive, well, if the discriminant is positive, that means you're going to have two real solutions. If the discriminant is negative, then that means you're going to have two complex solutions. If the discriminant equals 0, then you do have only one answer, but it's still, it's kind of what we call multiplicity 2. The answer there is there twice. So, but anyway, so what I want to say is factor in the quadratic formula. So I got a couple of examples, example 1 and example 2. And both of these I believe are going to factor for us, so it's going to be nice for us. So 3x squared plus 5x minus 2 equals 0. So the first thing I'm going to do is see if there's anything that comes out front, and there isn't. 3x squared, 5x, and negative 2 has nothing in common. So it's going to be what we're going to call a reverse FOIL, if you will. And so 3x squared, this is what's called the guess and check method. But there's not much to guess from. 3x times x, the first times first, must be 3x squared. So that's the only thing I could think of, 3x times x. The 2, well, the only factors of 2 are 2 and 1. It doesn't matter where you put them. If you put the 2 here and your 1 there, that's a possibility. If you put the 1 here and the 2 there, that's a possibility. So that's why they call it the guess and then check it. So I'm going to guess this one is 1 and this one is 2. And so if you FOIL 3x times 2, that is 6x. And then 1 times x is 1x. So that combination either gives me 7x or 5x plus or minus. And I do have a plus 5x. So if this one was a plus 6x and a minus 1x, I would get 5x. The only way this is going to be a plus 6 is if both of these are going to be positive. So that one's got to be positive. And this will be negative 1. So since this one is positive, that means this one is negative. And that'll give you the negative 1x. So you then check it to make sure. This is 6x, negative 1x is 5x. So that is the right combination that will give it to you. So let me erase this back out of here. So the zero factor property says that if you have two things and you multiply them together and it gives you 0, then one of those factors must be 0. So in other words, you were taught at some point, you should have been taught if AB equals 0, that implies A equals 0 or B equals 0. So that's the property I'm using here. So if this times this equals 0, then that means 3x minus 1 equals 0, or x plus 2 equals 0. So isolating the x on each of these equations, you get 1/3 for this one and negative 2 for that one. Okay? So we were lucky here that this one actually did factor. So, and that's the one right here. And you're like, well, can I just go ahead and use the quadratic formula for every one of these problems? Yeah, you could. You could use the quadratic formula on all of them if you wanted to, unless they specifically say factor. So, but if they don't say whichever way, you can go ahead and use the quadratic formula. Some people prefer just one way of doing it, and that's fine. But for me, factoring is a whole lot easier. If it will factor, if it takes me more than a couple of minutes to figure out which combination on my guess and check, then I'll just say, okay, I'll just go ahead and factor it then. So, but that doesn't happen very often. So, and in example 2, yeah, well, that looks rough. Well, not really. This one's got a little bit of flavor of section 1.1 when the fractions were here. So what I'm going to do is I'm going to multiply this one by the least common multiple, much like I did in 1.1. So if I multiply both sides by the least common multiple, that's x squared. So x squared times 6 over x squared plus 7 over x plus 1 equals 0. So it'd be x squared times 0 as well. So 6 times this one is going to be 6, because the x squares cancel. X squared times 7 over x is 7x. And then x squared times 1 is x squared. And then 0 times x squared is still 0. So just by multiplying by the least common multiple, that clears out all of your denominators, which is what we was hoping for back in 1.1, and that's what we're going to get here as well. Now what I'm going to do here now is I'm going to rearrange the terms to put it in the general form, which is what we talked about a while ago. Then I'm going to do the factoring on this one as well. And so this factors, and this one's actually an easy factor one. X times x is, of course, x squared. And 6, well, you got 3 and 2 and 6 and 1. And obviously, that's the 6 and 1 is going to work because you need a 7. So it's going to be plus 6 and a plus 1. And so like I did over here, when two things are being multiplied, you set each one of them equal to 0. So x plus 6 equals 0, and x plus 1 equal to 0. So x is a negative 6, and x is a negative 1. But this is one of those situations that we had back in 1.1 when we had denominators. And the restrictions for this one would be 0, because you cannot divide by 0. 6 divided by 0 squared, 7 divided, you can't do it. But 0 is not one of my answers anyway. So these numbers should work. So x equals negative 6 and x equals negative 1. But pay close attention. That first step is to get rid of those fractions. So how many of these types of 1.2 you have? Oh, a few. You got a few of them. But you're better off just by multiplying by the least common multiple. And so when you're solving equations that have fractions in them, that's always the first thing you want to do is clear out those fractions. So whether you're doing linear back in 1.1 or they're quadratic here in 1.2, that's still the game plan. So, all right, I want to finish this up with a couple more problems in my part 2. But But on those, we're going to use the quadratic formula. So stay tuned.